Okay, we're going to look at lesson 3, intercepts, symmetry, even and odd functions, and then intersections. So this first one, we're going to look at x and y intercepts. To find an x-intercept, the y value is always 0. To find a y-intercept, the x value is always 0. So we're just going to do some substitution. So example number 1, find the x and y-intercepts. X-intercepts, we're going to replace 0 for y. So to find the x-intercepts, not 0 y squared, we're going to do 0 squared. Minus 3 equals x. Well, 0 squared is 0. 0 minus 3 is negative 3. So your x-intercept is at negative 3. An x-intercept is an actual ordered pair, so we're going to write it as negative 3, comma 0. The x is negative 3, the y is 0. To find a y-intercept, we're going to do the exact opposite. We're going to put a 0 for x. So we would have y squared minus 3 equals 0. And now we need to solve for y. So we add 3. So y squared equals 3. We're going to take the square root of both sides. And remember, when you take the square root, it is both the positive and the negative value. So we have y is positive or negative square root of 3. A y-intercept is an ordered pair, so we have 2 of them on this graph, 0 square root of 3 and 0 negative square root of 3. Okay, next up we're going to look at symmetry. We have 3 types of symmetry. We have y-axis, x-axis, and origin. So y-axis, our x's are opposite of each other. One's positive, negative. The y's are the same. Over the x-axis, if we have symmetry there, the y's are opposites and the x's are the same. And then over the origin, they are going to be complete opposites. X is the opposite and y is the opposite. So there are some ways to test, and we have them right here. The y-axis, you're going to replace x with negative x, and it's going to produce the same equation. If it's a y-axis symmetry, replace y with negative y, and it's going to produce an equivalent equation. And then origin, you're going to replace both to get the same equation. If the same equation is produced, then that is the type of symmetry it has. You have some informal ways to do this as well. I'm going to stick with the formal ways on these next couple of examples. So we are going to find out what types of symmetry we have here. So on number 2, the first test I'm going to do is the y-axis. Remember, replace x with negative x. So y equals 2 times negative x to the third minus a negative x. We want it to produce the same exact. So negative times negative times negative is still a negative. So this would be negative 2x to the third. Negative negative makes positive. This is not the same equation as this. It has changed. So not y-axis. Let's check the x-axis. We're going to replace y with negative y. And then we've got negative y equals 2x to the power of 3 minus x. We want to get y by itself, so we divide. Y equals negative 2x to the third plus x when we divide everything. And that is not the same either, so not the x-axis. That was not x-axis, x-axis. So if it's not the y-axis and it's not the x-axis, we have one more to try, the origin. So I've written a little bit large, so we're going to go into this space right here. We're going to replace both this time. So negative y equals 2 times negative x to the third minus a negative x. So I'm going to deal with this side over here first. That's negative y still. This is negative 2x to the third. Negative, negative, this is positive x. Now get the y by itself by dividing, and we get y equals positive 2x to the third minus x. And it goes back to the original. So it is symmetrical about the origin. Example number 3, absolute value of x minus 2. So let's try the y-axis first. So y equals absolute value of negative x minus 2. Absolute value of anything is going to end up being the positive. So it's the same as writing the positive absolute value. So this and this are the same, so y-axis works out. Now let's try the x-axis. Negative y equals absolute value of x minus 2. Divide everything by negative, and it's y equals negative absolute value of x plus 2. That's not the same, so not the x-axis. And then we could try to do both of these. So we have negative y equals absolute value negative x minus 2. Remember we said this is the same, so negative y equals absolute value x minus 2. And then divide, and we have y equals negative absolute value x plus 2. And that's not the same, so not the origin. So this one is only the x-axis. Okay, on number 4, absolute value of y equals x minus 2. So replace the x first. Absolute value y equals negative x minus 2. Not the same, so not the y-axis. Replace the y. So absolute value negative y equals negative x. Whoops, not x, negative. It was a positive originally. Positive x minus 2. Absolute value of anything is the same thing as the positive. So we are back to the original. So x-axis is our symmetry. And then you could try the origin and do both. So absolute value negative y equals negative x minus 2. And then y positive absolute value is negative x minus 2. And that's not the same because of the negative x. So not the origin. Okay, even and odd functions. An even function is symmetrical about the y-axis. Odd functions are symmetrical about the origin. So you could use the test above, but we also have a different way of saying it. F of negative x is going to produce just f of x. So the original, just like we did with the negative x, is going to be produced again. And then odd, if you put negative x in, it's going to make the negative of everything in our equation. So let me show you what I'm talking about. So we're going to put negative x for everything. So number 5 right here, we're going to do f of negative x. If it turns out to be the same, it's an even function. If it turns out to be everything is opposite, it's origin. Okay, so we are going to do this first one right here. Negative x to the power of 3 minus negative x. So we talked about third power makes negative x to the power of 3. Negative negative is positive, so plus x. When I look at number 5, everything is opposite of what it used to be. Positive turns negative, negative turns positive. If everything is opposite, that is an odd function. Number 6, I'm just going to jump down a little bit because I ran over. We're going to put negative x in again. Okay, so when I do that, I have negative x squared minus 4. Negative times negative is a positive, so this is x squared minus 4. And notice that's exactly the same. So if it stays exactly the same, it is even. This one right here, replace x with negative x, and we've got negative x squared plus 2 times negative x plus 2. Negative, negative turns positive, so positive x squared. 2 times negative x is negative 2x, and then plus 2. Positive, not positive here. So this changed, but the others didn't. So it needs to have everything opposite or everything the same. And that didn't do either, so this is neither even or odd. So it's neither one of them. Last thing that we're going to look at is points of intersections, and this time we're going to do it without a calculator. So on a couple of videos ago I showed you how to do intersections in a calculator. We also need to do this algebraically. So I have these two equations, x minus y equals 1, and then x squared minus y equals 3. So you have a couple of different ways to do this. I'm going to use substitution. So I'm going to isolate a variable, and then I'm going to do substitution. I think getting y by itself is probably going to be the easiest because y is not squared and x is. So I'm going to take this one right here, and I'm going to solve for y. So I've got x equals y plus 1 when I add the y over, subtract 1, and I have y equals x minus 1. So now I have this that I can substitute in for this y right here. So what that looks like is x squared minus everything that is going to replace y equals 3. So the thing that replaces y is x minus 1. Now distribute that negative, and I have x squared minus x plus 1 equals 3. We should notice that this is an x squared, which means I'm probably going to have to factor to solve this. So I need everything over, and I need it set equal to 0. So subtract 3, and I get x squared minus x. 1 minus 3 is negative 2 equals 0. Factor that. This is a pretty simple one to factor. X times x is x squared. I need numbers that multiply to be negative 2 but add to be negative 1. So that's a negative 2 and a positive 1. Solve that, and I have x equals positive 2, or I have x equals negative 1. So this should give me a hint that there are two intersection points. So this is going to produce one of the intersections, and this is going to produce another. An intersection is a point, so I already have the x value, I need the y value. So you're going to go back to either of the originals and solve for y. Well, this one's really easy. So y equals x minus 1, which is 2 minus 1. 2 minus 1 is 1. Here, my x value is negative 1. I need to find the y. So y equals negative 1 for x minus 1. Negative 1 and negative 1 is negative 2. So my two points of intersection are this one and this one.